Hello children, in ray optics we are going to learn the combination of the media. Now see the refraction through the combination of the media, which is nothing but we have to take the rarer medium and one denser medium and another denser medium, like maybe water and one more denser medium, maybe the glass, you can take it, right? So now the refraction of the ray of light from air to water and from water to glass and finally to air. Is it right? See, as all boundaries are parallel planes, emergent rays parallel to the incident ray, right? For the ray which is going from medium 1 to medium 2, how we have to take, see the incident ray and the refracted ray, that is mu 1 2, which is equal to sin I by sin R. And same like we have to take it for the ray which is going from the medium 2 to 3, that means from B to C. So we have taken that mu which B to C, which is equal to sin R1 by sin R2. See the diagram, sin R1 by sin R2. In that same way we have to take it for from B to C, I mean C to A, the third one, right? So this is, we have to take it mu CA, which is equal to sin R2 by sin I, we have taken here, right? I1. So multiplying the above three equations, as we know, so what will come? Mu AB into mu BC into mu CA, which is equal to 1, as we know, right? So we can say this as mu AB into mu BC, which is equal to mu AC. Is it right? Yes. And also we can say this as mu BC, which is equal to mu AC by mu AB. That is medium 1 3 by medium 1 2. Have you got it? So this will help us to know the refraction through a combination of the mediums, right? Now the next one is, you must know about apparent depth and the real depths of a liquid. If suppose you can take the refraction of light, that the apparent depth of an object which is placed in a denser medium which is less than the real depth. See the diagram, a point O, the object O, which is placed at the bottom of the beaker, right, filled with some water. See the ray which is from the rarer medium to denser medium, it starts from that O and it is getting again refracted along the path, right? So these rays which is appear to diverge from that point, right? So we can say the virtual image of that O, which is, we can say that clearly the apparent depth, right? So the apparent depth, which is nothing but here we can mark the HA, right? The HA which is smaller than the real depth, which is HR, right? So this is, that's why we can say a water tank appears swallower, or an object which is placed at the bottom, it's appear to be raised. From Snell's law, we can say that, we know that very well from the two medium which is comparing with Snell's law proved that mu which is equal to sin I by sin R. So here we have to take it the water and the air. So we can take as usual mu BA which is equal to sin I by sin R, right? Or we can say mu AB which is equal to sin R by sin I, right? So we can say, as the size of the pupil is very small, or maybe we can take it. So here we can take only that part of real depth and the apparent depth. So we have to compare this to mu AB which is equal to real depth by apparent depth. Okay. See the apparent depth, which is nothing but what we said, real depth by apparent, the refractive index, we can say, right? From that relation, we can get the normal shift. So what is normal shift? The height through which an object appears to be raised in a denser medium is called a normal shift. So the normal shift, which means what? Real depth minus apparent depth. So that here we can take it h, or height of real depth minus height of apparent depth, which is equal to, we can write this hr minus hr by mu, because mu, which is equal to real depth by apparent depth, we can change the apparent depth, which is equal to real depth by refractive index. So we can rearrange this hr within 1 minus 1 by mu, right? So we have to know about what are the factors on which the normal shift in the position of an object depends. The two factors, that is the thickness of the refracting medium, and as well as we have to consider the refractive index of the denser medium. Depending upon that, both the normal shift will be changed, right? And also you must know the points. If suppose the observer is in rarer medium and the object which is there in the denser medium, how it will be? The height of the apparent depth is lesser than the height of the real depth. So we can say that an example, like to a bird, a fish appears to be nearer than the actual depth. Is it right? So same like if the observer is in denser medium and the object is in rarer medium, then the height of apparent is greater than the height of real. So to a fish, the bird, how it is appears? It is appears farther than the actual height, right? Now we can see the total internal reflection. So one of the very important phenomenon we must know about in this optics. What is total internal reflection, or TIR? The total internal reflection is the phenomenon of complete reflection of light back into the same medium for angles of incidence greater than the critical angle of that medium. How we can see, right? Now you can take the mediums, rarer medium and the denser medium. See, when a ray of light which is travel at a small angle of incidence from a denser medium to a rarer medium, right? See, we can say from water to air also, right? This as usual we can take an example, or glass to air. So the refracted ray bends away from the normal, so that the angle of refraction is greater than the angle of incidence, right? As the angle of incidence increases, the corresponding angles of a refraction also is getting increased. See that. So then, for a certain angle of incidence, what will happen? The angle of refraction become 90 degree. Is it right? So that the refracted ray goes along the surface of separation. That we can say that the angle of incidence in the denser medium, for which the angle of refraction in rarer medium is 90 degree, which is called the critical angle, right? So that is denoted by IC, R, which is equal to 90 degree, or you are seeing in that diagram. So if the angle, if suppose the incidence is increased beyond IC, the critical angle, the whole of the incident light is reflected back into the denser medium. See that? So this phenomenon is which a ray of light traveling at an angle of incidence which is greater than the critical angle from the denser to a rarer medium is totally reflected back into the denser medium, right? So that we are calling it as a total internal reflection, or TIR. Got it, children? Right. Now, what are the necessary conditions for this TIR? See, the light must travel from an optically denser medium to the rarer medium first, and the angle of incidence in the denser medium must be greater than the critical angle for the two medium. Got it? So what are the relation between the critical angle and the refractive index? See, from the Snell's law we can prove this. See, the critical angle is the angle of incidence in the denser medium for which the angle of refraction in the rarer medium is 90 degree. So IC which is equal to 90 degree, we have seen that. What is mu here? Mu GA, which is equal to from the denser medium to rarer medium, consider it, right? Which is equal to sin A by sin R, that is equal to sin IC by R is what? 90 degree. So sin 90 degree, which is equal to sin IC. Or we can write this as mu AG is equal to 1 by mu GA. Therefore what? Mu AG, which is equal to 1 by sin IC. We can write it, right, from the above relation. So sin IC which is equal to 1 by mu AG. Also we can write sin IC which is equal to lambda G by lambda A, right? Yes. So we can say the red color has the maximum value of the critical angle and the violet will says the minimum value of the critical angle for that. And sin IC, that critical angle, which is equal to 1 by mu AG, which is equal to 1 by A plus B by lambda square. See, what are the applications, or we can say that of TIR? The mirage, you may see, right, looming, and totally reflecting prisms, and we can say the optical fiber, right, and sparkling of diamond. Why it is getting sparkled? Because of the refractive index of diamonds is very large, so its critical angle is small, about 24 degree. So the faces of diamonds are actually so cut that the light entering the crystals, which suffers total internal reflections repeatedly, so that only it gets collected inside, but it comes outside through only a few faces, so that only the diamonds which is sparkles, right?